In this video, we will be discussing section 9.7, which begins on page 600 of your textbook and is entitled Factor Special Products. So previously, we've just gone through the regular process of factoring a quadratic, which is an equation with an x squared term, where a was 1, which is really nice to factor, and where a was different values in the last section. So we are continuing with factoring special products. First, let's go ahead and look at our first key concept. You can use special product patterns that you learned in lesson 9.3 to factor. So we're reversing the process here, such as the difference of two squares. So the difference of two squares, if you see something squared minus something else squared, it's going to factor into a plus b times a minus b. So I'm going to have alternating signs here, and then what we factor them into are basically the square roots of what is being squared here. So let's go ahead and look at an example. Factor the polynomial y squared. So this is the difference. It is a difference. That checks out for us since there is a subtraction sign here. And both of these are something squared. Alright, so write it as the difference of squares. So it becomes y squared minus 4 squared. And so then when I factor it, it's going to be y plus 4 times y minus 4. The next example, I've got 25m squared minus 36. We want to first rewrite it as the difference of squares. So 25m squared, you take the square root of that, and that is 5m. So the 25m squared is 5m, quantity squared, minus 6 squared. And then factoring that, you get 5m plus 6 times 5m minus 6. And one more example for you. X squared minus 49 squared, rewrite it as a difference of squares. So that becomes x squared minus the quantity 7y squared. And then you factor it. X plus 7y times x minus 7y. And you can always double check these by going backwards through the process and foiling, using your distributive property, combining your like terms, and you should end up back where you started with your original polynomial. Alright, example 2. Factor the difference of two squares. Now, you might be able to notice right off the bat, well, 8 is nothing squared and neither is 18. But what you should notice is that they are both even. So if I can pull out a 2 and undistribute that and reduce these numbers, maybe I can get somewhere from there. So I'm going to go ahead and factor out the common factor, which is 2. And then I notice that it is a difference of squares because I've got a 4 and a 9. Alright, so I rewrite that as a squared minus b squared, the difference of squares, 2 squared minus the quantity 3n squared. And then I rewrite it as the quantity 2 plus 3n times 2 minus 3n with a 2 out in front that I originally factored out. Alright, so that is fully factored. So, a couple of guided practice for you. Feel free to pause the video and a couple of solutions, and try these on your own, and then a couple of solutions will pop up on the screen for you. Alright, so going over that, you would rewrite it as 2y squared minus 8 squared, and then you'd factor it. Okay. Our next concept here is perfect square trinomials. So both of these patterns we've discussed before. We started out with one of these, all right, where I have an a plus b and that quantity squared, or an a minus b and that quantity was squared. And so we are working backwards, and we have what is produced. This is called a perfect square trinomial, either one of them, whether there is a plus or a minus sign. Alright, and as discussed in previous sections, this second sign when it is a plus sign tells me that when I factor it, both of the parentheses, both of the sets are going to have either a positive symbol or a negative symbol, a plus or a minus, when I factor them. And so that's how I know which one is which. And you have to do a little bit of critical thinking here as far as the numbers are concerned. So let's go ahead and hop to an example. Factor the polynomial. So right away I see that 36 and I see that n squared, and I know that I'd be able to factor that, but then I recognize, okay, the square root of 36 is 6. If I double that, that's 12. So this is a perfect square trinomial. That's the process I always think about, is take the square root and double it, and I should get that middle term here, that b. So I rewrite it in that form. By rewriting it in that form as a perfect square trinomial, I can see exactly what's happening. And then I can factor it. I can reverse the process. Right? By factoring the perfect square trinomial using that pattern, I get the quantity n minus 6 squared. Now, if you recognize it as okay, well, what are the factors? If instead, what are the factors of 36 of a positive 36 that add to a negative 12? Well, that's negative 6 times negative 6. So this is going to factor into n minus 6 times n minus 6. All right, which, since both of these sets are the exact same, you write that as n minus 6 squared instead. Going about it a different way for this particular example isn't necessarily longer, it's just a different way. So it is helpful to start recognizing these patterns so that you can shortcut it. Okay, example 3b. 9x squared, that's a perfect square, minus 12x plus 4, that 4 is a perfect square. And so let's go ahead and rewrite it as a perfect square trinomial. Alright, so I have my a term here, and I have my b term here, and then I multiply them and double it, and it does fit that pattern, so I can factor it into a 3x minus 2 squared. Alright, and one more example for you. 4s squared plus 4st plus t squared. Alright, the 4s squared is a perfect square, the t squared is a perfect square, and then if I take the square root of those, and then multiply them together and double it, I should get this middle term. So I'm going to rewrite it in my perfect square trinomial pattern, and that's going to allow me to go ahead and factor it. And if you're not seeing where these factors are coming from, I'll go ahead and go through all three of these really quick. So this means both of the signs are going to be negative. Alright, both of these signs are going to be negative. Both of these signs are going to be positive here. So that's where the signs came from. Now, where did the n minus 6 come from? Well, I confirmed that it was 6 times n. There's a 6 over here, there's an n over here. So there's the n, and there's the 6. I need to confirm that it was a times b here in the middle. Here's a, here's b. Alright, a times b for my middle term there. Here's a, here's b. That's where all those numbers come from. Okay, example 4. Factor a perfect square trinomial. So walking through a couple steps here, I initially see that a is negative, and it's a negative 3. So I want to see if I can not only get rid of that negative by factoring it out, but I want to see if I can get rid of a negative 3 as well. So I can factor out a 3 there, and 3 there. So I'm good to go to take that first step. So I factor out the negative 3, and then I go ahead and rewrite it. I see that this is a perfect square, this is a perfect square, and if I rewrite it, I do get that middle term is my a times my b. Alright, so then I can fully factor it with that negative 3 out in front, and I get negative 3 times the quantity y minus 6 squared. Alright, time for some guide practice. Go ahead, pause the video, and see if you get the same solutions. Moving on to example 5 here. Solve a polynomial equation. So we're pretty much going through the exact same process that we have before. We're just taking an additional 2 steps using the zero product property and solving after that factorization is complete. Alright, so with this example right off the bat, hopefully you see these dudes and dudettes right there, alright, those fractions. Now, I personally love fractions, but if you're not as big of a fan of fractions as I am, get rid of them. Alright, so how do I get rid of them? You need to look at the denominators, alright? I need to find a common denominator first and foremost. That common denominator is going to be 9, and so I want to multiply every single term on either side of that equation by 9. Alright, so here's my original equation. You always want to write that out. Multiply everything, every term, each side by 9. When I do that, my fractions should drop out. Okay, so then I can rewrite it as a pattern, which here it is a perfect square trinomial. And I can confirm that my middle term here is a times b. So then I can continue to factor it. Alright, so using the zero product property, I don't have 2 sets of parentheses here since I chose to write it with the exponent. So all I need to do is take that one set of parentheses, 3x plus 1, and set it equal to 0. Subtracting 1 from both sides, 3x equals negative 1, and then you divide by 3, and that is how you arrive at x equals negative 1/3. Alright, so the solution, the only solution, is negative 1/3. Example 6. A window washer drops a wet sponge from a height of 64 feet. After how many seconds does the sponge land on the ground? Right, so solution. Use the vertical motion model to write an equation for the height, h in feet, of the sponge as a function of time. So I'm going to have my variable h on one side and t on the other. Alright, so I need that equation for my vertical motion. Alright, so here is the equation for vertical motion. We've been using it fairly consistently throughout the chapter. I would definitely make sure that you have it written down somewhere and boxed so that you have it when you're preparing for your test. The sponge was dropped, so there's no initial vertical velocity. What that means is, the window washer wasn't throwing it downwards. He wasn't tossing it up into the air. So at time 0, it's starting with speed or velocity 0. So we need to find the value for when the height is 0, when it hits the ground, when it goes, alright, and hits the ground. So I substitute in a 0 for the velocity as well as for the height. And then a 64 in for my s, which is where s is your initial height. So substituting that in and then simplifying it, there's an additional step that Miss Hlebiczki would write out. That would be negative 16 t squared plus 64. Alright, so you would see that negative 16 in that a position, that coefficient, that leading coefficient, and hopefully you get a gut feeling that you wouldn't want that. Alright, so you're going to factor out that negative 16 like they do in the next step. And then you recognize t squared minus 4. That is a perfect square, that's a perfect square, so this is a difference of squares. So take the square root of t, boom. Make sure you have a minus and a plus, and then take the square root of 4 and put a 2 in each of those sets of parentheses. Alright, hopefully not creating as much of a mess with arrows as I do. So then you use your zero product property. Now what a lot of people are going to want to do is they're going to want to write in that negative 16. Since that negative 16 is a constant that you have, or it is, a constant or a coefficient that you have factored out here, since it's just a number with no variable attached right now, you don't have to worry about it. So we are purely just pulling out what is inside of the parentheses for the zero product property. Right, you set each of those equal to 0, you add 2 onto this one, you subtract 2 from each side onto that one, and then you get t equals 2 and t equals negative 2. Now let's think about it. What are they actually asking for in this word problem? They're asking for time. So, disregard the negative value. We can't go back in time, we don't have negative time. So the sponge lands on the ground after 2 seconds, after it's dropped. Alright, so let's try out some guided practice here. Go ahead, factor the equation, and then solve using the zero product property. Alright, if you guys have any questions, always feel free to send me an email. I look forward to hearing from you all. Good luck.